So net ionic equations, the net part is always when you cancel out things that are on both sides. You're simplifying something, in this case, simplifying a chemical equation to get rid of species that have the same count. They're exactly the same, they're both silver maybe, and they have the same state. So I have a balanced chemical equation, copper elemental solid plus 2 silver nitrate aqueous, so that's a water-based solution. They react and they make copper nitrate, and that's in solution, and then we get solid silver. That's probably going to fall to the bottom of our solution. Now we're about to start studying chemical reactions, and when we're studying them, we want to be able to look at reactions and get rid of what doesn't change, because when we're studying change, we don't care about things that stay the same. So we're going to convert this to net, and we're going to do a couple steps. First thing we're going to do is dissociate. That means to break up, okay, all highly soluble ionic compounds. Okay. So those would be ones that are aqueous. If an ionic compound is solid, then we have to leave it together because it's not highly soluble. Okay. Later, we'll learn more about acids and bases. And if we had a strong acid, we would break those up. Okay, now, we haven't talked about acids yet, so we're not going to see that part today. Okay. So break up things that are highly soluble. Now, it says aqueous right there. That's one of the things we're going to have to break up. We've got copper nitrate as a product. That's aqueous. That's highly soluble, so we're going to have to break that up. So that's what we're going to do in the first step. Okay. Then we're going to cancel out identical entities on both sides. When I say identical, it has to be the same species. So let's say copper, it would have to have the same state, so aqueous, and would have to have the same amount of them. Okay? The species would also have to have the same charge. So you can't get rid of a neutral copper and a copper 2+. They're not the same species. Okay. Last, we're going to rewrite the equation with what wasn't canceled out. And if we have, let's say, all even numbers, we're going to reduce those, okay? Because we always write equations with the smallest possible whole numbers. This is a skill while you're learning, you write it out. By the time you master it in Chem 20 or in Chem 30, you'll often do this in your head. We're going to write the whole thing out. So I'm going to rewrite it every time I get to aqueous, I'm going to break it up. So we have copper solid, that is not aqueous, so we can't break that up at all. We get to silver nitrate aqueous. The aqueous tells us that the silver ion has separated and is totally surrounded by water, and the nitrate has separated away and it's surrounded by water. But that would be horrible to write it separate all the time. So chemists always write the ionic compounds that are soluble together, even though they're both pulled away from each other and surrounded by water. We're going to pull that apart. So we've got silver and nitrate. The 2 applies to the silver and the 2 applies to the nitrate. There are 2 silver nitrates. When we break this up, there's going to be 2 silver plus. Okay. Your periodic table would remind you of the charge of silver if you weren't sure. Okay. And that's still aqueous. We're not changing the state. We're just going to write it separate from the 2 nitrate ions. So I've taken care of my copper. I've taken care of the silver nitrate. I expanded that out. So I'm going to move to my arrow. I've got copper nitrate, aqueous. So that we're going to break up and write separate. So I've got copper. Now I'm going to have to think of the charge, and your workbook or data booklet won't help you because there's 2 types of copper. Okay? We have to see what type we have. Now, nitrate is in your data booklet on the top above your periodic table, And NO3, one of them is negative, but there's two of them, so that's -2 between the two of them. So the copper has to balance that out. So this must be a +2 version of copper. That's how we get a neutral formula unit. Okay? So don't look at your table to grab the charges. You have to look at the individual units and get them to balance. So this is the copper +2 aqueous, and there's only one of them. There's no number in front of the copper, and there's no subscript, so they're both 1. So there's one copper. Next, we get to the nitrate, NO3- aqueous, and there's two of them. There's a subscript 2. Now, when we write the nitrate all by itself, that 2 goes in front for how many there are. Okay? We only use the brackets and the subscripts when we write formula units. Last, we have our silver. It's solid, so there's nothing to do. So this is our expanded equation. This is what you'll eventually do in your head once you get used to this. And now we look to cancel anything that's exactly the same on both sides. So our copper was neutral and turned to positive. So we can't cancel that out. The charge and the state is different. Okay? Lots happen there. Okay? In Chem 30, you spend a whole unit on the fact that this lost 2 electrons to become +2. And you can make a battery out of that. So lots of chemistry going on there. Silver went from positive to neutral and changed its state. So lots went on there. We'd want to study that. Nitrate, though, 2 NO3- aqueous, 2 NO3- aqueous. Nitrate did nothing. It's boring. It's not going to change concentration. It's not doing anything. So we want to be able to write nets where that is gone. So the net ionic equation is elemental copper. So think of a copper penny. Can react with 2 silver ions, aqueous. So that's a solution, a water-based solution. That is going to make copper 2+ and 2 silver solid. Now I have to be careful, but if I've pulled down all my coefficients properly, this should be still balanced. We don't have to rebalance it. The only thing we'd check to see is if we could reduce those whole numbers, and we can't. We have 1, 2, 1, 2, so you can't reduce below 1. So aqueous barium bromide reacts with aqueous sodium sulfate. We're asked to write a balanced equation with states. That's what you would have learned in Science 10. And then we're going to do the new Chem 20 skill, which is to write a net ionic equation. Okay? In your Alberta data booklet, it's page 6 that you're going to find the solubility table, and we're going to need those for the products. So the barium bromide, barium is a +2 ion. You maybe didn't get there yet to write down to figure out its charge, but barium's +2, so when it combines with bromide, which is minus, you need 2 bromides. And then you don't have to look up the state. We're told it's aqueous. Reacts with aqueous sodium sulfate. Sulfate in the polyatomic ion table is listed as a -2 ion. Sodium is in group 1, so that's plus, so that's why we need the 2 sodiums to balance out the -2 of the sulfate. Okay. These charges I'm writing in blue, you don't have to write in, you just have to realize them. So I like to write them in a different color. They're just part of your thinking. Now, let's see if you can do that double replacement. If you remember how to predict the states, do that. If you don't remember how to predict the states, you'll see that shortly. So I'm going to go through and predict the first product and the first state, and then we'll see if you can do the second product on the second state before I go through it. So this is a double replacement. So the barium, which is a metal and a cation, is going to want to pair up not with the sodium metal, but with the sulfate anion that's negative. So positive and negative have to go together. So that's what I'm predicting correctly as my first product. In terms of the charges, they stay the same. So barium is a 2+, sulfate is still a 2-, so I don't need any subscripts. +2, -2, that's a neutral formula unit. Okay. Now I am going to have to predict the state. So that's where your data table on page 6. You're not memorizing this. Now, the way the solubility table works is you start with the negative piece first. So even though you read barium sulfate, you don't start with the barium, you start with the sulfate. So sulfate on the top has its own column. And then we're going to go down, and we're trying to find barium, or the category that barium would fit in. So sulfate, if we go down, the first row is most. So most things are very soluble. So this is our aqueous section. In Science 10, it said aqueous. Now it just says very soluble, which means aqueous. Sulfate, though, with calcium, calcium-2, strontium-2, barium-2, silver, mercury, lead, or radium, most of those being +2. All of those are slightly soluble. Those are our solids. And we have sulfate with barium. So sulfate with barium is slightly soluble. We're going to have to use the solid state. So it's going to turn into a snow globe, probably a white powder, and that's going to fall to the bottom. So barium sulfate, solid, is our first product. I'll pause and let you finish the second product. So our second product comes from the other pairing. So that's going to be the sodium ion, which is positive, and that's going to pair up with the bromide, which is negative. Don't use those subscripts. Like there's 2 bromides in the reactant, but that has no connection to the product. So we have sodium, and that's a positive ion, and we have bromide, and that's a negative ion. So we just need 1 sodium and 1 bromide, and that's it. The 2 at the beginning below the bromide, that'll just show up when we balance this. Let's go back and look at the state. So we had bromide, and that was with sodium. So bromide with most cations is going to be very soluble, except for copper 1. Now really notice this, that's not copper 2, that's just copper 1. Okay, copper is multivalent. Copper, silver, mercury, we don't have any, sodium is not there. So bromide with sodium would be under the most, and that is going to be aqueous, very soluble. So we've found our precipitate, barium sulfate. Typically in double replacements, when you use them in a science lab, one thing precipitates and one doesn't. If both were aqueous, everything would cancel out in the net ionic and there'd be nothing left, and there'd be nothing to study because nothing would have happened. It's easy to rush. I sometimes go too quick and don't balance it before I do the net. We've got 1 barium, 2 bromides, double my sodium bromide. I've got 2 sodium, and I just got 2 sodium, 1 sulfate, so this is balanced. So we're not done, but we finished sort of the Science 10, balance, predict all the states, predict all the products. So now I'm going to write the Net Ionic. I'm going to orally talk about kind of the shortcut, and then I'll do out the whole thing. So if we scan it before we do the net, the barium sulfate is solid at the end, and it's obviously aqueous no matter where it is at the beginning. So the barium and the sulfate is not going to cancel out. What could cancel out is either the sodium or the bromide. So these are our possibilities where we'd focus. The sodium is aqueous here, and there the sodium is aqueous. Here the bromide is aqueous, there the bromide is aqueous. So it looks like both the sodium and the bromide are both going to cancel out. But let's do it out the long way, and that's what I'm expecting. So aqueous barium bromide, so we have barium 2 plus aqueous, plus we're going to write we got 2 bromides, aqueous. That's our first reactant. Second reactant has 2 sodiums and a sulfate. So I'm going to write the 2 sodium ions and the 1 sulfate ion. Again, I'm not checking tables. The state says aqueous, so I broke it up. Product side, we've got a solid. Okay. That is going to stay together, and it's going to be a precipitate. Okay. Fall to the bottom. Last, we have our sodium bromide. That's aqueous, so I break it up. The 2 applies to the sodium, and the 2 also doubles the bromide count. So this is the double replacements are quite long when you break everything up. Now we go to look for that canceling. The barium is aqueous to solid, so that can't be canceled. The bromide is exactly the same on both sides. So whatever its concentration is, it's not going to change. We don't want to study things, or we're not going to study things that don't change. 2 sodium plus, 2 sodium plus, they're gone. Okay. And the sulfate has to stay because it starts as an aqueous ion and turns into a precipitate. So when we're studying this reaction, we'd really just care about the barium concentration because it's going to drop. It's a reactant. And would care about the sulfate concentration because it's going to drop. Okay. And if either of those had colors, we would see those colors fading away. And we will predict in Chem 20 the mass of barium sulfate that would form.